My name is Mike Meredith. I'm the doctor of Doctor's Woodshop, and in this section I want to talk about walnut oil. All of the finishes produced by the Doctor's Woodshop are based on walnut oil. So what's so special about walnut oil? Now, walnut oil is one of the natural drying oils. Walnut oil, tung oil, linseed oil, poppy seed oil, but you don't see that very much. The natural drying oils are called drying oils not because they dry the way that water would evaporate and dry, but this form of drying is actual chemical rearrangement of the materials within the oil. The fatty acids actually cross-link to one another and form covalent three-dimensional structures that eventually become hardened plastic-like material. Now, linseed oil, when it hardens, becomes gray or black. Tung oil turns yellow when it dries. Walnut oil stays clear. They also differ, the three common drying oils differ in the rate at which they will set. Linseed oil sets up very fast. Tung oil not quite so fast. And walnut oil is actually the slowest of the drying oils. Now this has to do with the amount of unsaturation within the fatty acids within the oil. The other side of that coin is that linseed oil dries so fast it gives off heat and actually is a fire hazard, which is why the rules about rags and towels after using linseed oil or oil-based paints are so clear about avoiding fire hazards. Walnut oil would technically call in that same class, but chemistry is never really about absolutes, it's about rates. The rate at which walnut oil sets up is sufficiently slow that it doesn't give off enough heat to become a combustion risk. So the drying oils will harden without chemical dryers. Now, what are chemical dryers? Most common chemical dryers are metal ions, cobalt and arsenic being the most common. There are some organic dryers, things that stimulate the cross-linking of the fatty acid side chains one to another. But the drying oils don't need those. They will set up all on their own. And in fact, any polyunsaturated oil, even canola oil, given enough time, will harden into a plastic-like material. Remember I said chemistry is not about absolutes, it's about rates. It's just the rate of that is so slow that nobody wants to wait for it to happen. Although walnut oil is the slowest of the common drying oils in its setting time, we can alter the conditions such that we can speed that up. And we do this by introducing heat. The term friction polish comes into play here. We need the energy of the lathe to speed up the hardening of the walnut oil, speed up the drying of the walnut oil, for this to become the really useful turning finish that it is. So we can use walnut oil as a standalone finish. Brush it on, let the piece sit, and eventually it will harden into a protective plastic coat. But I think there are better ways to do it, although a lot of people finish their pieces this way. I use walnut oil most commonly as a sanding lubricant. Now, we wet sand metal, we wet sand plastic all the time. Why not wet sand wood, which is exactly what a sanding lubricant is. The sanding lubricant allows you to avoid some of the common problems with sanding. First of all, by dispersing the heat at the surface of the wood, you avoid the expansion of the oily material in the wood that produces a crack called a heat check. The denser the wood, the more common heat checking is a problem. Cocobolo, ebony, African blackwood, red heart, even black walnut is very sensitive to heat checking. And a heat check goes down into the wood. It doesn't go this way. So you wind up having to cut out a significant amount of wood to get rid of the heat check itself. More common advantage is that the sanding lubricant allows you to sand much faster. First, because you're sanding at speed. You don't have to slow the lathe down to avoid heat checking. Secondly, we forget that sandpaper is a cutting tool. By collecting the dust that comes off the wood, we make a dust oil emulsion which serves as a polishing compound. So we're polishing and sanding, cutting at the same time, and as a result we're going to get a much better surface from a given grit of sandpaper than you will without the lubricant. Okay, we're finally actually going to turn some wood. I learned very quickly when I started doing demonstrations of my product that if you're going to talk about finishes, you need to have something to finish. And I found that the bottle stopper was about the easiest thing to make because you're never more than about 5 minutes away from something that needs to be finished. So today I'm going to take this little piece of East Indian rosewood and rough that out into a bottle stopper, and then I'm going to show you the walnut oil as a sanding lubricant. This is sort of a new tool on the market. It's produced by Jimmy Clues. He calls it there's a first mate and a second mate. One is a little bit bigger than the other. It's a hunter cutter mounted into a stiff metal bar. And I haven't used it a lot, but I've been very happy with it. I think you can get these from Jimmy's website, jimmyclues.com. Now, one of the advantages to the use of a sanding lubricant is that you don't make dust. Now, as I said, this is a piece of Indian rosewood, and although I'm the only one here, I would never use Indian rosewood in a public demonstration because of the potential for allergy. Somebody walks by, gets a nose full of dust, and there's trouble to be had. But when you use a sanding lubricant, we're going to put that dust to work, making it the buffing compound, the polishing compound, so the dust stays on the sandpaper. So let me show you how this works. So we're going to use the walnut finishing oil. And this is just pure walnut oil that's been treated to remove as much of the protein as I can get out. And it's as simple a process as can be. I'm going to put the walnut oil onto the sandpaper. And here this is, let's see, what is this? This is 120 grit. I didn't do a very good job roughing this one out, but that's what sandpaper is for. Okay. There's the buffing compound. The wood trapped in the oil on the surface of the paper. The other thing this process accomplishes is that it's forcing the walnut oil into the wood. By the time we're done, we'll have a layer of walnut oil into even this very hard rosewood, somewhere between 1 and 2 millimeters deep. That oil is going to set up, become a plastic-like material, and that's going to protect the wood irrespective of any sort of film finish we might put onto it. You can see my fingers and the sandpaper are covered with the oil and sawdust mixture. I always sand way too long when I'm talking about it. This piece, that grit was done probably 2 or 3 minutes ago, so I'll try to keep my head in the game get through this piece. With sanding lubricant, you will sand faster and you will sand better. And as long as you're not talking to anyone, it'll take you a lot less time. Through the miracle of modern video editing, you're going to be spared about 5 minutes of repetitive sanding. I'm sure you've probably got the gist of the process by now. I've sanded up through about 600 grit now. I speeded the video up because who likes to watch someone sand? The last thing you do, though, is put a few drops of clean oil onto a paper towel and clean the surface. Hey, remember I said that we can change the conditions? We can speed up the polymerization of the walnut oil by heating it up. And once I've gotten all the dust and debris off the surface, that's what I'll do by friction polishing the surface. Okay, that looks pretty clean. Now this is just the blue paper towel from Costco or Shopco or whatever you have in your area. And what I'm going to do is actually squeeze the piece. And you need to feel the heat coming through the towel. What I'm doing is raising the surface temperature of the wood. Now in chem speak, the rule is Q10 equals 2. For every 10 degrees you raise the environmental temperature of a reaction, you double the rate. Remember I said walnut oil polymerizes at the slowest rate of the 3 common drying oils? Well, we're speeding that up right now. And it will get hot enough, and eventually you'll start to see a little bit of a shine on the surface from that polymerized oil. More importantly, the oil inside the wood has been being set up so that there's a layer of protection on the piece. You can see that the surface is bright and shiny, and more importantly, protected. Now this is only sanded to 600 grit. For rosewood, I would usually take it up to maybe 1,000, but as I said, who likes to watch somebody sand? There we have the bottle stopper with the Pins Plus finish on it, ready to go into service. Since most of you don't spend your time turning bottle stoppers, I thought I'd show you that the idea of sanding lubricant is also applicable to power sanding, that is for bowl production. I got here's a little cherry bowl that I just finished roughing out, and the final step in the bowl turning is a shear scraping step, and I saturate the surface with walnut oil to do the shear scraping, sort of like lathering up before you shave. But I want to show you real quick how you would go about using the walnut finishing oil as part of a power sanding routine. Now when you're going to be sanding a bowl with a drill, of course the walnut oil is going to go a little bit of everywhere, but on the inside anyway, it's actually pretty simple. If you just apply the walnut oil to the edge, rub it over the surface, and sand away. Now you're going to have to add more oil as the polishing compound becomes thicker. But to begin with, a little oil, rub it over the surface, and sand away. Most of our buffing compound is staying on the inside of the bowl. This is a 320 grit sandpaper disc. After the shear scraping, I am expecting about a 220 grit surface. So we'll start at 320 and go up to 420, maybe 600 on this one. On the outside, the drill is the same, except the oil tends to get a little bit further away from you, so you need to be adding more oil a little more frequently. And you can see there's our polishing compound, just like with the hand sanding. So I'll quick finish this up through the grits and show you how you finish the sanding process. I'm sanding at about 1200 RPM, about the same speed that the bowl was turned at. And that's it. It's that simple. Sand better, sand faster with the sanding lubricant. Now, to finish the process, it's just like we did before. We're going to clean the surface, then friction polish the walnut oil on the surface. So you can see there's quite a bit of dust still on the surface. We'll just clean it off, fresh oil. When I'm out doing demonstrations, we play the guess the grit game. I will sand a piece with a piece of sandpaper, then ask those watching the demo what was the last grit of sandpaper that I used. Invariably I'll be sanding with 180, but the guesses always come in 400, 600, 800. You do get a much better surface with a sanding lubricant. Plus you keep the dust out of the air. More importantly, out of your nose and out of your lungs. This is especially important if you're working with one of the Dalbergerons. Cocobolo ebony, persimmon, kingwood, or black walnut. The jugulones in black walnut will actually paralyze the little hairs inside the lungs that sweep stuff out. Okay, the piece is cleaned up pretty well. So now I'm going to find a clean spot of towel, put on some fresh oil. Now throughout this process I've used probably an ounce or less of the walnut oil. Now friction polishing the surface. Raise the temperature, speed up the polymerization reaction, get the oil in the wood to harden and provide a protected surface. Now this becomes important particularly with bowls that are going to be used for salad bowls, let's say. The depth of 1 millimeter doesn't sound like a lot, but if you look at the bottom of a salad bowl, you'll see that there are scratches that are very likely that deep. And having that polymerized walnut oil inside the wood just extends that layer of protection. And there we have it. We'll zoom in a little bit so you can see the surface a little bit better. No tool marks, no sandpaper marks. Just a nice piece of cherry, sanded quickly, relatively speaking, producing a better surface and a more useful piece. Well, that's it for this section. Thanks for dropping in.